Now we study the integrals which are reducible to one of the standard forms that we have previously seen. Now in that there are a couple of different formats. Let us study the first out of them. Here we have the integral of the form 1 upon ax square plus bx plus c. So that means here the integral has a quadratic term in the denominator and the numerator is 1, or it may be any constant which can be taken out. So it is a quadratic in denominator. Now to complete this, what do we do is we complete the square in the denominator. So that means first of all we have to take a common outside the denominator, and then in the remaining expression we have to complete the square, so that the integral can be reduced to any one of the previously known forms, that is something like 1 upon x square plus a square, or 1 upon x square minus a square, or 1 upon a square minus x square. Of course here instead of x we can also get something like px plus q. That means it can be a linear expression in x also, that is px plus q the whole square plus a square, or we may get px plus q the whole square minus a square, or here we may get a square minus px plus q the whole square. So once we arrange the expression in one of these three forms, we can use the standard integrals to evaluate it. So let us see one question based on this type. Evaluate integral of 1 upon 2x square plus 4x plus 1. So we observe that there is a quadratic expression in the denominator. Now as we have seen, we have to first make the coefficient of x square term as unity. So we must take 2 common from the denominator. So what remains is x square plus 2x plus the constant term now will be 1 by 2, isn't it? So if you want to complete the square here, we see the two terms are x square plus 2x. So obviously we need 1 to complete the square. So that is nothing but 1, right? And since we want to adjust 1 by 2 and we have already written 1, so that means we must ultimately subtract 1 by 2, so that 1 minus 1 by 2 gives us the 1 by 2 as we had previously, right? So writing the denominator now in the square form, that is the first bracket, which is x square plus 2x plus 1, can be written as x plus 1 the whole square, right, minus 1 upon 2 can be written as 1 upon root 2 the whole square dx. So if you observe, we have got the integral of the form 1 upon x square minus a square, where as we have seen previously x can be any linear expression in x also, okay? Still the standard result is equally applicable, alright? So therefore now using the standard result we have the answer as 1 upon 2 multiplied with, in the standard result we have 1 upon 2a, and where a stands for here 1 upon root 2. So therefore we'll write 1 upon root 2. Then we have log of, since it's x square minus a square, we have log of x minus a upon x plus a. Now here our x is nothing but x plus 1, minus a means minus 1 upon root 2 upon x plus a. Once again x means x plus 1 and a is nothing but 1 upon root 2 plus c. So now we have to just simplify this. Now if you observe, the root 2 will cut with the root 2 and only root 2 will remain. So we have 1 upon 2 root 2 log of, now on multiplying with root 2 we can write it as root 2 into bracket x plus 1 minus 1 whole upon root 2 into bracket x plus 1 plus 1 plus c, which is the final answer. So the idea is that we have to complete the square in the denominator and reduce it to one of the standard forms. Now let's see another variety. Now here we have the integral of the form px plus q upon ax square plus bx plus c. So it's like integral of linear upon quadratic. We have to identify and remember these patterns. So if it is of the form linear upon quadratic, see what we have to do is this numerator we have to somehow write as some unknown constant, say a, right, into the derivative of denominator, that is ax square plus bx plus c plus some constant b, right. So here the uppercase a and uppercase b are the two unknown constants that we have to determine so that the numerator can be written in this particular format. Now what's the benefit of doing this? So let's see. Assume that we are somehow able to write the numerator in this form. The denominator is still the same. So what we have to integrate basically is this, right? So now if we break that, let's see, here we have to integrate the first part in which a is a constant, so that will come out of the integral. So I can write d by dx of, let me write in short the denominator as q, which stands for the quadratic expression, whole divided by q, right? This is to be integrated, plus in the second integral, b comes out and you have within the integral 1 upon q. Now if you observe, the first integral has the form that derivative of a function upon the function. So therefore its answer is nothing but log of mod of that particular function, isn't it, as per the standard result. And here we know how to integrate the function of the form 1 upon quadratic, which we have just seen, and we have to complete the square in the denominator and integrate. So therefore in this form what we have to remember is we have to express the numerator as a into derivative of denominator plus some constant b. Alright, so let us solve one question based on this so that this procedure will be clear. Evaluate integral of 2x plus 3 whole upon x square plus 5x minus 7. So the numerator is 2x plus 3, and let us consider what is the denominator of the derivative, denominator of the denominator, the derivative of denominator term, which is 2x plus 5. Right. Now if we compare this with the numerator, we already have 2x plus 3 in the numerator, whereas the derivative of denominator is 2x plus 5. So therefore the numerator 2x plus 3 we can definitely write as 2x plus 5 minus 2, isn't it? So here our a is actually equal to 1. We don't need to write anything other than 1, and b is nothing but minus 2, correct? So therefore our integral is equal to 2x plus 5 minus 2 whole upon x square plus 5x minus 7 dx is equal to, now we can break the integral, that is 2x plus 5 upon x square plus 5x minus 7 minus 2 into integral of 1 upon x square plus 5x minus 7 dx. Now we know that the first integral is the log of the denominator, that is log of x square plus 5x minus 7 minus 2 times. Now we have to solve this particular second integral by completing the square. So just for the sake of simplicity, let's call it as I1 and solve it separately. So since we have a quadratic, we want to complete the square, so therefore that is x square plus 5x. Now to complete the square, we must divide the middle coefficient, that is 5 by 2, which is 5 by 2, and add and subtract its square, so that is plus or minus 25 by 4, right? So that is minus 25 by 4 minus 7. So therefore this gives us 1 upon the complete square is the square of x plus 5 by 2, the whole square, minus, here we get 25 plus 28 whole by 4 inside the bracket. So therefore this is equal to 1 upon x plus 5 by 2 the whole square minus, now 25 plus 28 is 53 and 53 by 4. So therefore 53 by 4 can be written as square of root 53 by 2 the whole square. Now this is of the form, once again, integral of 1 upon variable square minus constant square. So that can be written in the integral as, here we have 1 upon 2a, so that is 1 upon 2 into root 53 upon 2 log of mod of, in the numerator we have x minus a upon x plus a, so that is x in our case is x plus 5 by 2, right, minus a is nothing but root 53 upon 2 whole upon x plus 5 by 2 plus root 53 upon 2. So that equals, here 2 will get cancelled and we are left with 1 upon 53 log of mod of, multiplying by 2 we have 2x plus 5 minus root 53 whole upon 2x plus 5 plus root 53 plus c, of course. Now this is the answer of just I1, alright. So we have to substitute I1 with the answer that we have got here, and that completes the final answer.